Welcome to Module 2 of Introduction to Crop Cultivation. We will be looking at crop selection and planting in this module. Lesson 1. Agroecological Zones in Nigeria. Nigeria is characterized by diverse agroecological zones, each with its unique climatic conditions, soil types, and vegetation. Understanding these agroecological zones is crucial for selecting suitable crops and optimizing agricultural productivity. Major agroecological zones in Nigeria. 1. Savannah Zone, located in the northern part of Nigeria, suitable for the cultivation of cereals, legumes, and oilseeds, including maize, millet, sorghum, groundnut, and soybean. 2. Forest Zone, located in the southern part of Nigeria, suitable for the cultivation of tree crops, including cocoa, oil palm, rubber, and cashew, as well as root and tuber crops, such as cassava, yam, and sweet potato. 3. Mangrove Zone, located in the coastal areas of the Niger Delta region, suitable for the cultivation of rice, coconut, and other salt-tolerant crops. Crop suitability and adaptation. When selecting crops for cultivation, it is essential to consider their suitability and adaptation to the local agroecological conditions, including climate, soil, and water availability. Criteria for crop selection. 1. Climate adaptation. Select crops that are well adapted to the local climatic conditions, including temperature, rainfall, and photoperiod. 2. Soil suitability. Choose crops that are suited to the soil types and fertility levels of the farm, considering factors such as pH, texture, and nutrient content. 3. Water availability. Opt for crops that require the available water resources, considering factors such as rainfall patterns, irrigation facilities, and water holding capacity of the soil. Market demand and economic viability. Assessing market demand and economic viability is crucial for selecting crops that have a high market value, demand, and profitability potential. Factors to consider. 4. Market demand. Identify crops that have a high demand in local, national, and international markets, considering factors such as consumer preferences, price trends, and market access. 5. Economic viability. Evaluate the profitability potential of selected crops, considering factors such as input costs, yield potential, market prices, and return on investment. 6. Diversification and risk management. Opt for a diversified crop portfolio to spread risks, enhance resilience, and optimize farm income and profitability. Lesson 2. Planning and designing your farm. Designing farm and layout involve organizing and arranging the farm's physical and spatial elements to optimize agricultural productivity, efficiency, and sustainability. Key considerations. 1. Farm size and land use. Determine the total farm size and allocate land for different crops, including food crops, cash crops, and rotational crops, based on the farm size, soil type, and agroecological conditions. 2. Farm layout and spacing. Design the farm layout and spacing to facilitate efficient farming operations, including planting, cultivation, irrigation, and harvesting, while maximizing the use of available land and resources. 3. Infrastructure and facilities. Plan and develop essential infrastructure and facilities, including access roads, water sources, irrigation systems, storage facilities, and processing units, to support farming activities and enhance productivity. Crop spacing and arrangement. Crop spacing and arrangement play a crucial role in optimizing plant growth, development, and yield by providing adequate space, sunlight, and nutrients for each plant. Key principles. 1. Plant spacing. Determine the optimal spacing between plants and rows based on the crop's growth habit, size, and requirements for light, water, and nutrients. 2. Intercropping and mixed cropping. Practice intercropping and mixed cropping to maximize land use, improve soil fertility, and reduce pest and disease incidence through crop diversity and synergistic interactions. 3. Crop rotation and succession. Implement crop rotation and succession to optimize soil health, manage pests and diseases, and enhance crop yield and quality by alternating different crops in the same field over time. Infrastructure and facilities. Developing appropriate infrastructure and facilities is essential for supporting and enhancing farming operations, productivity, and profitability. Key requirements. 4. Access roads and transportation. Develop access roads and transportation facilities to facilitate the movement of farm inputs, equipment, and products within and outside the farm. 5. Water sources and irrigation systems. Identify and develop reliable water sources, including rivers, boreholes, and reservoirs, and install efficient irrigation systems, such as drip irrigation and sprinkler systems, to ensure adequate and timely water supply for crop growth and development. 6. Storage facilities and processing units. Construct and equip storage facilities, such as barns, silos, and warehouses, and processing units, such as mills, dryers, and factories, to store, process, and add value to agricultural products, improve market access, and increase income and profitability. Lesson 3. Introduction to crop rotation and intercropping. Principles of crop rotation. Crop rotation is a farming practice that involves alternating different crops in the same field over time to optimize soil health, manage pests and diseases, and enhance crop yield and quality. Key principles. 1. Crop diversity and rotation. Rotate different crops, including cereals, legumes, and oilseeds, to improve soil fertility, nutrient cycling, and organic matter content by fixing nitrogen, increasing soil carbon, and suppressing soil-borne pests and diseases. 2. Rotation patterns and sequences. Implement different rotation patterns and sequences, such as simple, complex, and cover crop rotations, to diversify crops, break pest and disease cycles, and improve soil structure, water retention, and aeration. 3. Rotation planning and management. Plan and manage crop rotations based on the farm's soil type, climate, and cropping system to optimize crop yield and quality, reduce input costs, and enhance soil health and sustainability. Benefits and importance of crop rotation. Crop rotation offers numerous benefits and importance to crop farming, soil health, and sustainable agriculture. Key benefits. 4. Soil health and fertility. Improve soil health, fertility, and productivity by enhancing soil structure, nutrient cycling, and organic matter content through crop diversity, nitrogen fixation, and soil-borne pest and disease suppression. 5. Pest and disease management. Control and manage pests and diseases by disrupting their life cycles, reducing their population, and enhancing the natural enemies, microbial activity, and beneficial organisms in the soil through crop rotation. 6. Crop yield and quality. Increase crop yield, quality, and profitability by optimizing nutrient availability, water use efficiency, and crop performance through proper crop rotation, soil management, and agronomic practices. Techniques and methods of intercropping. Intercropping is a farming practice that involves growing two or more crops together in the same field during the same growing season to maximize land use, improve soil fertility, and reduce pest and disease incidence through crop diversity and synergistic interactions. Key techniques. 1. Row intercropping. Plant alternate rows of different crops, such as cereals and legumes, in the same field to optimize land use, improve soil fertility, and enhance crop yield and quality through complementary growth, nutrient cycling, and pest and disease management. 2. Mixed intercropping. Plant mixed crops, such as vegetables and herbs, together in the same field to maximize land use, diversify crop production, and enhance soil fertility and productivity through synergistic interactions, mutual benefits, and complementary growth. 3. Strip intercropping. Plant strips of different crops, such as trees and shrubs, together in the same field to optimize land use, improve soil fertility and structure, and enhance biodiversity, water conservation, and ecosystem services through complementary growth, root interactions, and soil protection. We have come to the end of Module 2, let us now move to Module 3.